Hey guys, welcome to part two. We are going to graph some of these irrational, crazy looking graphs. I'll show you the process, but let me point out real quick before I zoom in here. Basically what we do is, and if you watched the first video, you would know, we want to establish any vertical asymptotes, dashed lines, barriers where the graph can't go or bends towards. And then, like a lot of graphs, we can use this for any kind of graph. We're going to do an XY chart to finish that up. So, like I said, we're going to zoom this puppy in. Give myself as much room as possible. And let's go to this first problem. Okay, first problem on the bottom has an x plus 1. If you watched the last video, you would know we need to establish what number I cannot use for x here. Well, if I plug a negative 1 in there, I would have 0 on the bottom, and that's a no-no. So that establishes my vertical asymptote, and I draw a vertical dashed line down through negative 1, and I know that's a barrier. I cannot draw through that line. My graph will get closer and closer to him, but will never actually touch him. So this is a vertical asymptote. What I'd like to do here is move up to, just real quickly, this graph we did a while back in the previous video. I just want to show you something as far as horizontal. So we didn't discuss horizontal in this one, but hopefully you can see that this little barrier right here, this graph's getting close to and close to. So here's what we're going to do. I could have went ahead and figured out what this point was. It would have been negative 2 comma something, but it's getting really close to 0. I could have figured out what that point is. It would have been negative 3 comma something, but it would have been really close to 0. So if I were to keep trying points, eventually it's going to get so darn close to this dashed line, I'm going to know exactly where that dashed line is. So if I were to plug in, say, a really big number like negative 100, it would tell me where I'm close to. And on the other side of the coin, clear over here, if I was to plug in positive 100, it would tell me where that graph is getting really close to out there. So we're going to apply that down here on this problem that we started. So an XY chart, remember, under any circumstances for a graph, will get you some points. So what I like to do is this. I want to put an XY chart over on this side of the graph for what's going on the left side, and I'm going to put an XY chart on this side of the graph for what's going on the right side. So I can't graph negative 1. That's what that dashed line is for. But I could probably graph negative 2 and figure out what happens there. And then if I plug in a really big number like negative 100, it'll tell me where that dashed line is going to be or where it's getting close to. So I'm going to do this one time just to show you, and then from here on I'm going to use a calculator. If I was to plug in negative 2 to that original problem, I would have negative 2 times negative 2 on top. So all I'm using is the original problem right here. And I would have negative 2 plus 1 on the bottom. That would give me a positive 4 on top. That would give me a negative 1 on the bottom. And I can divide those two guys, and I obviously get negative 4. So again, from here on out, I'm just going to use a calculator to do that. And, you could certainly use one of those red calculators, graphing calculator, whatever calculator you have to plug that stuff in. So at any rate, negative 2 comma negative 4 right here. Okay, now here's what I already know. I know that this graph cannot go past that dashed line. So I know he's getting close to that guy and not going past. But what I don't know is where this graph's going to top out at. So where's the horizontal spot? And that's why we plug in negative 100. And I'll tell you what, I will do this one more time. If I plug in negative 100 to the original problem, that's the top. That's the bottom. Now, I am going to go ahead and ring that up on a calculator. I'm going to tell you it comes out to be negative 2.02 with a whole bunch more decimals to follow. But what we're saying is, though, negative 2.02 is really pretty darn close to negative 2. So that tells me that my horizontal asymptote goes through negative 2. And really just one point will suffice here, because if I have to draw my graph up towards that dashed line but not go through him and get close and close, then he's got to bend like that. So he's restricted that corner where all the dashed lines are. So really all I have to do is come over here on the right side of the graph and get one dot, and I know where those lines have to go. So again, dashed line is at negative 1. I can't graph him, so I could pick 0, which is on the right side of that dashed line, and I'll plug him in. Now again, I'm going to use a calculator from here on out. So just imagine that I am plugging a 0 in for x, and I am plugging in a 0 for x right there, and I'm going to tell you that that comes out to be 0. So 0, 0. Oops, I missed by 1. Let's try that again. How about right there? And I will point out, though, it never hurts to try a big number on both sides. So if I were to plug in 100, use a calculator, it comes out to be negative 1.98 with a whole bunch more decimals following it. But if you see, negative 1.98 is pretty darn close to negative 2. So same thing. The graph is diving and getting really close to negative 2, but not going through it. And I can't go past the dashed line, so he's getting really close to the vertical dash line, but never going through it. And those dashed lines are called asymptotes. They're a barrier where the graph never goes through. And that's what a rational function looks like, at least for that one. So let's try this one on the right. A little more involved. I want to know the restrictions. When in doubt, factor it out. So if I factor this guy out, it'll make it way easier for me to tell what numbers I can't use for x. So 3 and 2 to get me a 6. Plus and minus to get me a negative 6. And that will also work out to get that 1x that's in the middle. So correct factoring. I assume you guys will trust me on that. So x cannot equal negative 3. X cannot equal positive 2. Otherwise, I get 0 on the bottom. That's what we do first. We establish our vertical asymptotes. So down here through negative 3 is an ungraphable region. My graph will get close to that, but never go through it. At positive 2, same deal. So I make my vertical asymptotes. So this time, I'm going to make 3 XY charts because this graph has 3 regions. So we'll call that the XY chart for the left portion of the graph. That guy's going to be the XY chart for the right portion or the middle portion of the graph. And this one I'm going to use for the right portion. So left, right, and center. All right, let's plug some numbers in. So if I plug in negative 4, which is to the left of the dashed line. So again, this is a calculator thing. You can plug negative 4 into that problem. I don't have time or space to do it, but I am going to tell you it ends up being 0.83 approximately. So negative 4, 0.83 is right about there. If I plug in negative 100, which is a big number, and it'll tell me where I'm getting close to, it ends up being 0.0005, which is awful darn close to 0. Now I'm going to leave the dashed line out of the middle because the asymptote doesn't necessarily go all the way across the graph. So my graph gets really close to that. And really close to that. All right, tough to draw. I will definitely give you that. All right, center section. I'm going to plug in negative 2. I'm going to plug in 0, and I'm going to plug in 1. And the reason for that is you just never know what that middle portion of the graph is going to do. This guy ends up being 125, negative 1.25. This guy ends up being negative 0.83. And this guy is also negative 1.25. So here's why that's important to do multiple coordinates. So I plugged in negative 2, and I got negative 125, which is right about there. I plugged in 0, and I got negative 83, which is right about there. And this guy's right about there. Well, the only way I can connect those 3 dots, guys, I'm heading down, so I keep going down. I'm heading down, so I keep going down. So I get sort of a loop-de-loop on the bottom there. The right side of the graph, I could plug in 3 because he's past the dashed line. I might plug in 100 just to check out, see where he's going. This guy ends up being 0.83. This guy ends up being 0.00049. More decimals, but the point is it's really close to 0. Graph that one. 3.83 is right about there. And I know this guy gets really, really close to 0, but does not go past him. So again, connect it, getting close to the dashed line, but not through it. Bends toward the dashed line and not through it. And there you go. So to be honest with you, you really have to do that in the center, and the reason is this. You can get all kinds of possibilities in the center. It can do a snake thing. Uh-oh. I'm going to run out of time here, guys, but it can do all kinds of things in the middle, and the only way you can find out for sure is to try a couple points and see what direction the graph is going. Thanks.